Welcome back to G Fun Facts Online, where we explore the science that sounds like fiction, but is very, very real. Today, we're talking about something that could change everything. Imagine a world where a surgeon can print a living, beating patch of heart tissue, perfectly tailored to a patient. Or picture a city where buildings can heal their own cracks and actively clean the air around them. This isn't a movie script from 100 years in the future. This is the rapidly emerging reality of printable organics and engineered living materials. It's a revolutionary field that merges the pinpoint precision of 3D printing with the incredible, dynamic potential of living cells. So how does it work? Scientists are moving beyond inert materials, like plastics and metals. Instead, they're creating what they call bioinks. Think of a specialized gel, absolutely teeming with living cells. This bioink is then printed, layer by delicate layer, to build complex, three-dimensional structures that are, for all intents and purposes, alive. The magic really begins with that bioink. It's a substance carefully engineered to give the cells both structural support and a nurturing environment to grow and thrive. Most of these inks are hydrogels, which are basically water-swollen polymer networks that are very similar to the natural matrix that surrounds cells in our own bodies. This similarity is key because it makes the cells feel right at home, allowing them to grow, communicate with each other, and organize themselves into functional tissues. By embedding different types of cells, like stem cells, muscle cells, or even genetically engineered microbes, researchers can create materials with a staggering array of functions. The potential applications are as diverse as life itself, and they are poised to revolutionize medicine. For years, we've faced a critical shortage of organs for transplantation. 3D bioprinting is tackling this head-on. While printing a full, complex organ is still a huge challenge, the progress is stunning. For example, a team at Boston University has already developed a micro-scale replica of a human heart chamber that actually beats on its own. Scientists have also printed living skin grafts complete with their own network of blood vessels, which could be a game-changer for burn victims. We're also seeing the creation of miniature liver tissues that can produce vital proteins, and printed kidney tissues being developed to fight renal disease. A company in Poland is even working on a bionic pancreas, using a patient's own stem cells to combat diabetes. But this technology isn't just for healing the human body. It's also for healing the planet. By harnessing the power of microorganisms, scientists are creating materials that can improve our environment. Imagine concrete that can autonomously repair its own cracks, making our bridges and roads more durable and sustainable. Picture building facades embedded with algae that absorb pollutants, literally turning our cities into giant air purifiers. We could even deploy living capsules with engineered bacteria to detect toxins in our rivers and lakes in real time. And the innovation doesn't stop there. The next wave is moving into the fourth dimension with 4D bioprinting. This involves printing objects with smart materials that can change their shape or function over time, responding to triggers like temperature, light, or your body's own chemistry. This could lead to medical implants that adapt as you heal, or drug delivery systems that release medication at a specific time and place. Now, as amazing as all this sounds, we need to be realistic. There are major hurdles to overcome before this becomes part of our everyday lives. Scaling up from a tiny lab sample to a human-sized organ is incredibly difficult and expensive. Creating the complex network of blood vessels needed to keep thick tissues alive is one of the biggest challenges of all. And of course, as we start creating living, partially human-made tissues, we have to navigate a very complex ethical landscape. We need to have serious conversations about the use of genetically modified organisms, the moral status of synthetic life, and how to ensure everyone can access these incredible technologies. Despite the challenges, printable organics and engineered living materials represent a true paradigm shift in how we create our world. This field holds the promise of a future where medicine is truly personalized, our cities are sustainable, and the line between the built environment and the biological world begins to blur. The age of living materials has dawned, and with it, a new chapter in human ingenuity is being written. Thanks for tuning in to G Fun Facts Online.